The statement made in the citation of science depends on an extrapolation of concepts. That is, the speed of light is measured indirectly, and, even though the measurement is very accurate, it depends on some form of remote tracking of information. Any such tracking takes time. Once they know the speed of light, astronomers virtually shift time's ground zero from our position to the star's position. When they did so, they would be neglecting the curvature of space associated with the uncertainty of the position of the light source. When you see a star, it appears with the appearance it had in the past, not the one it would have at this very moment. Centaur Alpha is a star that belongs to the constellation of Centaur and can be seen, at night, to the north of the constellation of Southern Cross. It appears well south of the Centaur, alongside its dimmer companion, Beta Centaur, with whom it forms a binary. Centaur Alpha has physical characteristics very similar to our Sun. If the star replaced the Sun, you probably wouldn't notice the difference. Another characteristic of the star is that it moves relatively quickly in the night sky. This gave astronomers confidence to say that it is the star that is closest to us, located 4.3 light-years from where we are. If we were to consider that the behavior of Alpha of the Centaur was similar to that of one of those incandescent lamps that, to shine in the night sky for the first time, had depended on the flick of a current switch, we could try to understand some principles of the relativistic view of events, which applies to the universe of the infinitely large, as well as to the level of atoms. It is likely that the Centaur's Alpha shone in the night sky for the first time long before the first intelligent being noticed its presence. The instant the current switch had been turned to the on position, the distant star lamp would have started to emit light, which we could consider to be our ground zero of time. For the observer on distant Earth, the light bulb could only be seen after 4.3 years, due, in principle, to the limited speed with which light travels through a vacuum. In this case, and from the point of view of an observer on Earth, the star's light would be traveling from the star's present to a future point in space, which, sooner or later, will be reached by our planet. Until then, the planet will move outside the star's future cone of light, and the star would still not be visible in the night sky. Even so, it is known that both would remain in the same dimension of time, that is, in the present. Some stars would be so far away that their light would not have reached us yet. That is, they do not exist for us, even though they are there. The curious thing is that, when the light of Centaur Alpha reached Earth, for the first time, the lamp star could be seen instantly on north of the Southern Cross constellation, without the observer being able to measure any time interval that had elapsed before the arrival of light. The zero time frame, which was supposedly placed at the position of the star, now appears at the position of the observer. This would allow the influence of the star's gravity force to be felt by the observer instantly and from a distance. Note that this placement will depend on our point of view. In this sense, Newton's statement was correct. The apparent movement of inversion in the direction of the arrow of time where the observer occurs, therefore, by principle of exclusion of direct access to time in the future, or to that entire interval of time in which the light of the star was being retained, in principle, because of its limited speed. As the Earth and the star move quickly in the night sky, when the light arrives close to the observer, Centaur Alpha would be seen out of its real position. After that first moment, the star would continue to provide access to the information carried by its light, with time apparently flowing continuously. it will only cease to do so at the time of its death. The finding that the current switch could be simultaneously in the position of the star and of the observer would place the zero mark of time continuously in our position, because our interpretation is what gives meaning to what we observe from a distance. It's a matter of points of view. Thus, it can be said that the star's light has always been with us, and it is impossible to say that it would have moved in space at an earlier time. The placement is in line with the idea that everything in the universe would be coexisting at the same moment in time, which points to the existence of a static universe outside the continuous flow of time. There would be no way to shift the zero frame of time from our position to the position of a distant star, unless an intelligent observer in an imaginary spacecraft could be passing by. One physicist suggests that the gravitational wave, which would be caused by the abrupt death of Centaur Alpha, would only reach us after 4.3 years. They are taking the risks involved in placing the beginning of the clock next to the star. In reality, they would be making an abstraction, extrapolating concepts towards the future. If we are rigorous, the time needed for Alpha's light to reach Earth would be indeterminable. The reason is that the speed of light is established by a process of remote tracking, done after the input of the reports. Remote tracking of light can be useful and acceptable, albeit inaccurate, for celestial bodies that perform cyclic orbits around the Sun. This would be the case for the other 7 planets besides Earth, and so the comets, as we know where they will pass in the future. If a massive celestial body were to penetrate the solar system and on a collision course with Earth, by the time it was detected, it would likely be too late. In the case of Centaur Alpha and the other stars, their cycles would be so long that the error in assessing their position would condemn the use of parallax, one of the ways of tracking light. This is very difficult to accept without some suspicion, but it allows us to suppose that the observer, in some way, has his share of responsibility in this whole process. It seems that, by being dependent on his memory to interact with the universe, reality is always beyond his direct reach. That is, the observer looks at the present of the universe as if he were in the past, which must be some kind of illusion that would be supported by his memory. For its part, the universe doesn't even care from our points of view.